Here is the receiver circuit. The receiver circuit consists of a buffer, a hold pulse connector, and a transistor again which is acting as a switch. We have a RC time circuit which will create a sample and hold signal for the reconstruction of the modulating signal. So for this, the connections to be made are output of natural sampling circuit to the input of buffer on the receiver side. And for this, we also need the same clock signal which was used at the transmitter side, because the time duration used for the pulses on the transmitter side and the time duration for the samples or the pulses to be regenerated on the receiver side must be same. There should be synchronization between transmitter and receiver. So we are connecting the same clock, that is S clock, to the hold pulse. So we can make the connection from S clock to hold pulse, or we can make the connection from A output of the control block to the hold pulse, because they are giving the same signal. Now with these two connections and the capacitor connected in the circuit, there are two options for the capacitors by which we can change the RC time constant, thereby changing the speed of charging and discharging of the capacitor, which will impact the accuracy of the reconstructed signal or the output signal. Now with these connections, with these three connections, let's now observe the output of the receiver with reference to the sampled signal. So one probe is to be connected to the output of naturally sampled signal and another is to be connected to the output of receiver. With this, we can observe on the screen the yellow colored signal is the sample and hold signal, while the blue colored signal is the sampled signal, naturally sampled signal. Now how this receiver works, let's try to understand. Now when we have the sample at the input of this buffer and the clock gives a high pulse or a positive pulse, then the transistor in the receiver is turned on. It is acting as a switch and it is acting as a closed switch and it will be turned on. The sample at the input of the buffer of the receiver will be available at the collector terminal of the transistor. When the transistor is turned on, the sample will be connected to the emitter terminal of the transistor and it is available to the capacitor for charging. So the capacitor C1 will now start charging to the amplitude of the sample. So if you look at the waveform, see here the pulse is available, the sample is available, so the transistor is on and the capacitor gets this sample amplitude for charging. So the capacitor starts charging towards this sample amplitude and it will follow the amplitude changes in the sample. Now between two samples, the level of the voltage is 0. Similarly, the clock pulses, for the clock pulses, these are two consecutive clock pulses and in between two clock pulses, the voltage level is 0. So here, in this case, now the hold pulse has become 0 or 0 volts. So this transistor is turned off. Now the capacitor do not have any voltage to charge further. So what it will do is it will continue to hold the previously charged voltage till the next sample comes. So when the next, so you can see between these two samples, the amplitude of the sample which was hold constant is hold constant, to which previously the capacitor was charged is hold constant. And when the next sample comes, the capacitor will start charging to the amplitude of the next sample. Again, between two samples, the transistor is off. The capacitor will continue to hold the previously charged amplitude and it is not a smooth continuous signal. To convert this signal into a smooth continuous signal which will resemble with our modulating signal, we have to use a low pass filter. Low pass filter has a transfer function of a sync pulse and this will allow the low frequency signals to be passed and convert the discontinuities in the signal into a smooth continuous waveform. So let's do this connections. The output of the receiver, that is the sample and hold circuit, is to be given to the low pass filter available here. So the output of receiver, we will be connecting to the low pass filter and we will connect the probe to the output of low pass filter. With this, you can see we have got the continuously varying sine wave which is demodulated or reconstructed signal. So if you can see, still we can see there are some discontinuities in this signal. If we change the sampling frequency to a lower value, then again we will observe that there will be distortions in the reconstructed output. So now I am again changing the potentiometer near 555, and we will observe that now the samples are getting reduced and the distortions are getting introduced in the reconstructed waveform. We can also observe the change in the modulating frequency will also affect the reconstruction of the signal. Now, let's see if I change the modulating frequency by using the pot near this generator block. So if I increase the modulating frequency, what happens? Whether the distortion increases or reduces. Let's see. You can see if I increase the modulating signal frequency, the distortion is increased. This happens because we have kept the sampling frequency constant and we have increased the modulating frequency. And as per the sampling theorem or the Nyquist rate criteria, sampling frequency should be at least twice the modulating frequency. When we keep sampling frequency constant and if we increase the modulating frequency, the Nyquist criteria or the Nyquist rate, that is Fs, should be greater than twice Fm, is not satisfied. So if we are using the modulating or increasing the modulating frequency, accordingly, we also have to increase the sampling frequency. So the sampling theorem or Nyquist rate is satisfied and we get undistorted, smooth, continuous output.